Hi, welcome to my video on the derivative using the chain rule, and this is again introduction number 3. The derivative using the chain rule. Is the function composite? Let's check to see if it is. A, x squared plus 3x, that's the sum of two functions. One is x squared and the other one is 3x, and the answer is it composite? No. And the square root of 6x minus 8, well, the f of x could be x, root x, and the g of x, which is the composite, could be 6x minus 8. So 6x minus 8 is going in the x in the root. So this is the f of the g of x. Also, this is a composite function, so this is a yes. And this is a yes. Explain. We have the f of x is, notice we got x, this is an x to the fourth, and the g of x, which is what's going inside, is 1 over 3x plus 2. So again, the g of x is going in the f of x, so it's the f. So it comes out to be f of g of x as a composite, so that's a yes. And this is a composite function also. Let's explain. The f of x is sine x. The g of x is 4x. So the 4x is going into place of x. Again, this is the f of the g of x, so this is a composite function. Also, because they're composite functions, we can use the chain rule. So let's do more practice on identifying that. Let's look down below. If composite, state the outer function and the inner function. So the f of the g of x is what we're going to signify it. The outer is going to be the f of x, and the inside is going to be the g of x. So here, this is composite. So if it is composite, then the outer is, almost made an error there. This is cos x being squared. So that means the outer one is x squared, and the inner one is cos x, because cos x is the inner one, being the x here is being replaced with cos x to give you cos squared x. And the outer one here is ln x, and the inside one, which is the g of x, is 2x, make sure, 2x plus 1. So 2x plus 1 is the composite going in the f of x to become cos of 2x plus 1. C is a composite also. So the outside one is the x cubed, because the cube is, this is inner, this is outside, and the inside one is x squared minus 2x. Again, this binomial is being subbed in the x here to give you this composite. And right here we have a composite, and the outside is x 2 to the x, and the inside is x minus 6. So the x minus 6 is composite, is being subbed into x here. So it gives you 2 to the x minus 6. And this is a composite function, and the outside is x to the negative 2. That's outside, so this is x to the negative 2. And the inside is root x plus 4. Again, when you do composite, this is the g of x going in the place of x in the f of x. And this is also a composite function, and we got this 3x over x plus 1 is inner, that's the inside, and the outside is x to the fourth. So this is the composite. So again, 3x over x plus 1 is going into the x in the f of x. So they're composite functions, and this is no. This is not a composite function. Is sine and e of x is the difference of two functions. So that's doing inner, outer, and inner. So what happens is that, let's go and find the derivative of each of these. And when we do the derivative of a composite function, so the f of the g of x is a composite function, g is going in f, then the derivative is the derivative of f with the g of x inside times the derivative of the g of x, which is what's on the inside. So let's do the derivative of cos cubed x. So cos cubed x is the same as the cos of x being cubed. So that means that the f of x is x cubed and the g of x is cos x. So when we do the derivative, which is in terms of x, of the cos cubed x, then we get the derivative of f, which is derivative of f, we're going to do the cos x cubed. So that's the derivative of f with the cos inside times the derivative of the g of x, which is what's on the inside. So there's the g of x, so we got the cube, which is the outside. Cube is the outside, and this is the inside. So the outside is the derivative of cos x cubed, and again, cos x is inside, and the g of x is cos x. So that gives us 3 cos x being squared times the derivative of cos x, which is negative sine x. And when we simplify that, we get a negative 3, we could say sine x cos squared x. Again, we got a power of cube, so we do the derivative of the cube, leaving cos x on the inside, which is the composite, and the derivative of the inside, which is the cos x. Number 2, very similar. We have the rewrite. This is 6x square root is 1/2. Again, the f of x is x to the 1/2. The g of x is 6x. So when we do d dx on 6x to the half, we do the derivative, we do 6x to the 1/2 derivative times 6x derivative. So there's the g of x, there's the derivative of the f of x with the g of x inside. So the derivative of x to the half is 1/2, and that's, take away, subtract 1 from a half, we get 6x to the negative 1/2, and the derivative of 6x is 6, so that becomes half of 6 is 3, and that becomes 6 to the x to the 1/2, so that's 3 times, that's a negative, so that's 1/6 to the 1/2, and so that becomes 3 times 1/the square root of 6x, and we can keep on simplifying that by rationalizing if we want to. 6x root 6x, and that gives us 3 times root 6x over 6x, and that is square root of 6x all over 2x, if you want to keep simplifying it. Number 3, we want to do the derivative, and again, we have f of x is the, I'm going to be careful here, f of x is x to the 4th, the g of x is 8x squared minus 5x. So d dx on the 8x squared minus 5x to 4th power, we do derivative of 8x squared minus 5x to the fourth power. So there's the derivative of the f of x with the 8x squared minus 5 inside times the derivative of 8x squared minus 5. So I'm following this pattern here. So the derivative of the f of x with the g of x inside, and there's the derivative of the g of x, which is what's inside. So that's derivative of fourth power is 4, 8x squared minus 5 cubed. 4 goes in front. 4 times 1 is 4, and that decreases by 1 to give me 3. And the derivative of 8x squared is 8 times 2 is 16. 2 subtract 1 is 1. And we get a linear, so negative 5x derivative is negative 5. So that gives us altogether, if you want to put that together or just leave it, you can put it in there, you put it here. So you could get, if you want, 4 times 16 is 64. I like to multiply that incorrectly. 64x minus 20 times 8x squared minus 5x cubed. Again, notice with these first three, the power is the outside. So this is x to the fourth. The power is the half, and the power is the 3. So let's do a few more examples. Find the derivative of each. Now, this time we have the f of x is the ln x, and the g of x is x squared plus 3. So if we do d dx, which is the derivative of ln of x squared plus 3x, again it's a chain rule because it's a composite, so we do the ln of x squared plus 3x, so that's the derivative of the f of x with the g of x inside, times the derivative of what's inside, which is x squared plus 3x. And so that gives us the derivative of ln x is, this is 1 over x squared plus 3x. So the derivative of ln x is 1 over x, so the derivative of ln of x squared plus 3x is 1 over x squared plus 3x times the derivative of the inside, which is x squared plus 3x, which is here, is 2x plus 3. So that gives us 2x plus 3 over x squared plus 3x. Hopefully you're getting used to the idea of how to use the chain rule. Again, this is a composite function. Just we have f of x is tan x. G of x, which is what's going in, is x squared. So we have derivative d of x of the tan of x squared, and that is the tan of x squared as derivative times what's inside, which is x squared, g of x. So the derivative of tan is secant squared, and we have, so if it was tan x, it'd be secant squared x. Because we have tan x squared, so it's secant squared of the x squared times, and the derivative of x squared is 2x, so that becomes 2x times secant squared x squared. And one more, we have to do the derivative, so this is an exponent, so again, this is composite function, f of x is 3x, the g of x is 4x minus 6. So d dx of 3 to the 4x minus 6, derivative of that is, again, it's the derivative of all of it, which is that, and we have times what's on the going on the inside, which is the 4x minus 6 derivative. So that derivative, so the derivative of 3 to any power is 3 to that power, and it's times ln 3. If you memorize the shortcut without working it out fully, we did this in previous videos. It's the derivative of this function times the ln of the base, and that's times the derivative of this is 4. Derivative of 4x is 4, derivative of 6 is 0. So that gives us 4, you say ln 3 if you want, and you could say times 3 4x minus 6. So I had to put that multiplication sign there so the 3's won't get mixed up, because this is a base 3. This is a value of 3, the ln of 3. And here we have it as a base. So if we put the two 3's together, you could probably make it the ln of 9 x to the 4th, but that would be incorrect. So that's explaining when you do the derivative using the chain rule, it's because you have composite functions, and that's how we work them out. Hopefully you see the pattern, and if you do, and you like my video, click on the like button, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.